Hi and welcome to Electrolisa. Today we're going to talk about a project which is called SimTram. SimTram is a simple device based on a microcontroller, an Arduino board, and a few tactile switches, one joystick and one LCD display. It's actually supposed to allow you to play with a control switchboard of a tram or a train, which is a simulation of it. It should be fairly simple and it's actually a lot of fun to build together, like a father-son enterprise. During the build of this project we came to a few interesting ideas. One of those was that actually having an Arduino board makes it simple to control an actual train, and we had one at home. So let's take a look at this. This is like a Lego set, Lego City 651 tram, and we decided that since it is controlled by a infrared controller, then it should be fairly simple to control it via Arduino, and ta-da, it is. So there is a library which allows us to do that. Okay, so first of all, let's take a look at the design, the functionality of the device, and then at the basic building blocks and how it works. Alright, so let's take a look at the actual in-field testing on our professional Electrolisa testing track. So we have a train ready, and the speed is actually set to 0 km/h, so it's like initialized. We have the 12-volt power on, so let's move the train forward. So we're pushing the joystick ahead. As you can see, the tram is moving with some reasonable speed. Let's move it farther. As you can see, the speed increases every around 10 km/h on the display. Okay, might be a bit dangerous. Okay, our test track is actually, well, I don't think it's used up to this kind of speeds. Okay, let's move it to 40. That's all I'm ready to do. Okay, I think that's high enough. Let's slow down. And we'll bring it to a halt in the same position as we started. Slowing down, beautiful. Let's see. The speed gets down. Okay, we have like a, let's move it further, and then let's bring it to a stop. And it did. Okay, so let's switch it off. Okay, so let's take a look at the design from the functional perspective. We have a power switch, a key, turnkey switch, then a power meter which will show the voltage of the power source. Then there's like this round 128 by 128 display, an arcade joystick, 3 arcade push buttons with LEDs, and one additional on top of this. So let's turn the power on. We see the display is actually booting. It shows like a welcome logo. Then it should default to the 0 km/h speed, which is the default. Okay, now the buttons are not programmed yet. We will do that at the later time. But what works right now are the speed controls, so we can actually push the joystick front, and the speed is actually increasing. It's quite slow, but you can set this speed of change in software. Once you let it go, then it's slowing down by 1 km/h every 3 seconds. You can also push it backwards, then you get like a braking action. Okay, once you push it over some preset limit, it's actually changing the color of the display to show this way of warning the user too big of a speed. That's all from the functional perspective for now. Do expect to have it like a door opening and locking mechanism, like a buzzer for the passengers and stuff like this. And let's take a look at the insides of it. So let's switch it off. Okay, so let's open it up. As you can see, it's like a real crazy amount of cables. The cabling is actually intentional, meaning that the amount of cabling is needed for it to be easily opened by me. So you have like two internal parts. One is an Arduino Mega, one is a custom board which is used only for crossing the connections between the buttons, joystick and the Arduino. It has a power source which is actually coming through one of the holes in the side of this design, and there's like a IR diode mounted in here. As you can see, it's very tightly wrapped with a cable. That's all she wrote for this montage. And it's actually, if you take a look at the controls itself, this is the voltage meter, this is the turnkey ignition, so to say. These are the push buttons. Two of the cables are actually being used for the switch itself, two for the LEDs. And there's, I don't know if you will be able to see it, but there's the joystick as well in here, which has two contacts for each of the directions. Let's take a look at the schematics. This design is being powered by plus 12 volts DC. Then the power goes through the ignition key to the Arduino's power supply input, which is then regulated. This plus 12 volts is then regulated to plus 5 and plus 3.3 volts that Arduino utilizes internally. On the other side we have of the switch, we have a analog voltmeter which is showing the voltage applied to this entire design. Then we have a DF Robot TFT LCD screen. It's a dot matrix display with a resolution of 128 by 128 pixels. It is being driven by an SPI interface directly from Arduino. Then to actually control the train we use an arcade joystick with 4 tactile switches. Each switch is responsible for its own direction, so it's up, down, right and left. How we operate it is actually very simple. So we connect one side of each switch to a plus 5 volts that we get from the Arduino board. The other goes to the Arduino digital inputs, and it's also being pulled down by a 10K resistor to the ground. It prevents an unknown state on each of the lines, and it also limits current in case it's flowing through here. Then on the other hand we have the 4 tactile push buttons. It's also an arcade design. Each one of those is also connected to plus 5 volts on one side. On the other it goes to the digital inputs and then to the ground via the 10K resistors. The idea is that each of those push buttons has its own LED. We will utilize them later in the design, but so far they are not connected, so I did not depict them on this schematic. Alright, thank you for sticking so far. Let's talk about the next steps for the project. So as you saw, the tactile switches, the push buttons that we have on the design, they are not working yet. The LEDs are not programmed as well, they are not even connected. The display is actually almost not used, it's only showing the speed. And well, let's say there's a lot of ideas that we can extend this project by. So this will live for later episodes if you would like to see those. Please subscribe to the channel, give it a thumbs up and leave your comments in the comment section below. And let's see each other in the next film. Goodbye.